Yeah, sure. Okay. So beginning again, my name is Thomas. I have got this small company called Android Devices. Here we basically design and develop embedded systems. So these are basically products which use microcontrollers to do stuff like that. So, uh, so this is literally the first product which I had developed. This was sometime in 2006. Okay, so this was before IoT was actually a word in the horizon. So what this was doing is this was a check drop box. So in those times you never used to have online payments. So this is like when the dinosaurs were roaming around, that kind of a situation. So in those times what people used to do is they used to come and drop a check in a box. Okay, and in the evening somebody used to come and collect those checks, write it all by hand and then send the checks to the bank. So we had kind of automated that entire system. So what here happens is you come and put your check inside, it scans the check and reads the mica reader on the check, okay, and then you input your mobile number, etc., and it will store everything and send an SMS to the Hutch server. Hutch was a company back then.
Yes.
So then they used to kind of update their systems real time and send you an SMS back saying that we have received your payment. Okay, so this was literally one of the first products we had made. So initially this was the first product which I did some hacking or whatever you want to call it. So that's a Nokia phone you see up there. Okay, so we had actually read the protocol of that Nokia phone, and then we used to send SMSs via that Nokia phone by sending data from the microcontroller. Then we found that Nokia keeps updating their models, and then we used to have to keep changing. So then we went for a GSM modem. So this entire thing was done back then. And this is another similar product which we had made for Tata Indicom. This is a footfall tracker. They used to mount this on all their gallery kiosks and everything, and it used to count the number of people coming in and out, and then it used to send an SMS to the server saying that in this kiosk so many people have come in and out. So basically this was meant for tracking if they make an ad, what is the effect of the ad, whether the number of footfalls have increased and stuff like that. So this was used for that. So feel free to stop me and ask me questions, otherwise I'll just keep rambling on. This is one of my bread and butter products which everybody keeps talking about. That's an elevator. That's a card which is used in an elevator. So when you push a button and all that, so the inputs come to this card, and then this card will actually decode what is the floor it is supposed to stop at. So when you have in some lifts you will see there are two buttons, some lifts you'll see there are one button. So there's a lot of different things like down collective, up collective and all that stuff. So when you press a button for going up, and if the lift is going up, then only it will stop at that floor. Whereas if it was going down, it will not stop at that floor. So all that logic is built into these things. So if you see that biggest black color chip over there, that's basically what's called a microcontroller. So you would write code on your PC and then load it into that, and that does the thing.
So which MCU you were using?
Sorry?
Which MCU are you using?
Oh, it changes. It depends on the product wise. So this MCU, what had happened was somebody somewhere I got access to an auto rickshaw meter. Okay. so I opened that auto rickshaw meter, and then I saw what chip they were using inside. So the idea was that if it's used in an auto rickshaw, it will be a very robust chip. And since it's being used in such huge quantities, its rate will be cheap. So then I use that one for the lift. Okay.
So is it from ST or?
Pardon me?
Is it from ST Micro?
No. This is from a company called Luoton. That's a Taiwanese semiconductor company. So STM, Microchip, they are more expensive things. So this is meant for Janta industry. Okay. So this is what is like now. So this is what a lift panel looks like. So if you go to any lift room, which is right at the top, you'll see a panel like this. So that's the board which I am talking about, which is made by us. So those would get all the inputs and all coming from these wires and all that. Okay, and and then it will decode it and send commands to this big box here. That's a drive. Okay, so that actually controls the motor which rotates the thing and takes the thing up and down. So that's what you heard. That was a contactor coming on. So you would have a huge motor and stuff like this, which will actually rotate it and bring it to your particular flow.
It's actually that guy is rotating, right?
Sorry?
Huh? That guy is in the picture, me rotate karta hu.
अच्छा उसका चेहरा आएगा. So yeah, so this is one of the products.
So do you sell these chips to like Otis and Kone?
No. So this is a separate bracket. What happens is Otis, Schindler, Kone, over a period of time when they sell it to all these societies, the people find it unaffordable to maintain that because they charge a bomb for doing that. So then what happens is our people go there and say, "Bhai, wo nikal do aur hamara dal do, ye bhi chalega." So then they put this and then take it. And of course, there are a lot of first installations and all that stuff. So we have provided almost something like 10,000 units of this running all over India. Okay, so this is another product of mine. So it's actually for fire detection. Okay, so if you see, there's a lot of fire detection things here also.
Yeah.
So those are those smoke detectors. So here, what happens is, now the smoke detector, what happens is you wait for the fire to have actually caught on and the smoke to have started generating, then you trigger the alarm. So these are mounted in bank vaults and stuff like that, okay, where they store things like currency notes and all that. So you don't want the fire to, like, you know, catch on in the thing and then detect it. So what this does is actually it detects the ultraviolet emitted by a fire. So it can detect a candle flame from something like this much distance. So it can detect both ultraviolet from a fire as well as from electric sparks. So this tube which you see there, that's actually manufactured by very few companies. So it's manufactured by a company called Hamamatsu in Japan. So the cost of the tube is something like 2,500, whereas a smoke detector is 700 rupees. Okay, so yeah, so what was nice about this was that tube actually requires 300 volts for excitation. Okay, so we are powering it with a 9-volt battery. So there is that little transformer there which actually generates that. So then, since it's powered by a battery, you want a long life and you want a long voltage. So then you write the code to kind of balance both. In the sense you send pulses, then go to sleep where the power consumption is low, then wake up again and that kind of a thing. So okay, there should be some voice here. So that's kind of the distance. So it can detect a candle flame, or actually we were using a lighter.
It needs line of sight.
A cone of, yeah, like a cone, divergent cone. So you would put multiple of these units. And the funny thing about this is, if this triggers, it will trigger the other one also. So if there are 2-3 of these units, if one triggers, it gets triggered by the other. So you have to mount them in such a way that they both don't see each other. And at the same time, that helps also because the area of coverage gets increased.
It is like if one point is triggered, then other should be like.
So there's a whole bunch of products like this. So this is actually a servo stabilizer. These are used with CNC machines and all that. So wherever there are huge drives and all that, what happens in places like which are on the outskirts of Mumbai, the power is not so good, and most of the industrial units are generally centered there. So what happens in the evening or in the night, when a lot of the units shut down, the voltages go high. So if you are running a machine at that time, it's not bad.
Yeah.
It's not good for that. So this would be basically monitoring the voltage and correcting it. So here you actually have to do a bit of engineering in the sense that you have to understand what is RMS voltage. Then you have to actually measure the sine wave bit by bit, do the computation, carry out that thing, and then do the correction. So these are kind of motors here, which you can see. So those motors actually rotate on that drum. That's a variac. Okay, so that's actually a transformer whose voltage can be varied. So that will rotate that and then maintain the voltage.
Can you not use electronics for this?
Yes, you can. But then what happens is, actually it will be much more faster than this.
And cheaper also.
No, it will be exorbitantly high. Okay, because these we are talking about like 100 kVA kind of loads. Okay, so if the load is less than say 5 kVA and stuff like that, then it might be somewhat on par. But when the loads become very high, then these kind of rule the roost. And the other thing about this is the equipment which this is actually servicing, it does not require fast correction. Okay, it basically requires that the voltage should be maintained in that range. So if you take the SMPS, which is for your laptop,
that's what I was coming to.
yeah. So if you take the SMPS voltage of a laptop,
Consumer
exactly. So they say it will work from something like 90 volts to 280 volts.
Yeah.
Yes.
But if you actually operate it at 280 volts, its life will come down drastically. Okay, whereas it can take that 280 volt ka spike ya jo bhi hai. But if you operate it continuously at 280 volts, its life will deteriorate. So that's where these products come in. So they will centralize the voltage over a period of time so that, fine?
But basically the main thing is that the load is very
Correct,
high.
exactly. So you want to bring it to a safe operating range. Even though they have specified a high voltage, you don't want to operate it continuously at that voltage. So just to keep up with the flavor of the session, IoT or whatever you want to call it. So this was a mock-up I had made for somebody who wanted to actually see like what happened. So what I have done is I have my board there, which is the stabilizer board. Okay, and I have connected on that top. There's something called an ESP32. Okay, so through that ESP32, so any product can be made into an IoT product. It's just that you have to add a Wi-Fi module or something like that. Okay, so that is there. And then this is a free offering from Arduino called Arduino IoT Cloud. Okay, so to develop that product took me about 3 to 4 months. To get this working, it took me about 3 to 4 hours. Okay, basically because all the libraries and everything are all available. It's a matter of just understanding the thing and plugging it in. So it's kind of like a dashboard. Whatever is the voltage there will be, yeah.
ESPs work on the DC supply.
Yeah.
Can you speak
Everything
louder
works
so
on-
the camera can catch up before you speak?
Everything works on DC supply.
So how come you are able to get the 3-phase voltage?
Okay, great. So this that board, the main stabilizer board, that does all the calculations and everything. Okay, and then it connects to the ESP32 via UART. Okay, so whatever is the readings which are captured by that, only the readings are sent to that ESP32. So the ESP32 is not doing any processing whatsoever. It's only taking the data from here. So it's like connecting something to your laptop via the USB. So you just send all the data to that, and then that connects with all the Wi-Fi and does all the remaining part of the processing. So all the calculations of RMS and whatever, it's done by this board.
The black board.
Yeah, no, the one with that big display. And then that sends the data to that ESP32. And then, so the one more advantage of that is in case your ESP32 conks out, your product will still be working. So it's kind of distributed. So that is typically the route I would follow for any of my IoT products. If I were to make something, I would have one to do actually all the heavy lifting, and then probably use the ESP32 just for the connectivity. Of course, you can use ESP32 for doing all the calculations here also. But then, yeah, it's like what you wish to do. Yeah.
If you can throw light on the industry standards for these products.
Industry standards are, for example, for the stabilizer, okay, or the elevator, you have BIS standards. That is Indian ka standard hai. So you can download that standard which is pertinent to your product and see what kind of things. Like for example, if you take a stabilizer, they say that you should control the output voltage within plus or minus 2%. So that's what they give. They don't say that you have to use this code or you have to use these components, or they don't say that. They only say that what is the expected output from the product. So like for example, in the case of an elevator, they will specify that if there is a fire, so there is an input coming from a fire sensor to your card, then in that case, what should the lift do? As in, it should come to a particular floor for clearing out the people, or it should come down the ground floor and not operate at all. So all those things are specified by the standard. But the standard never says that you have to use this microcontroller or you have to use these components or what like that.
So all voltage stabilizers will have UART or SPI or
No. See, this product is designed by me from scratch.
Okay, that's why it is.
Okay, so since there were some spare pins which I could route as a UART, just to give a demo, I had hooked up that and done it. So it depends on the microcontroller you use. If you use a very small, cheap microcontroller, it might not have enough pins to do that.
And you're using like a current transformer to...
Yeah, so there would be a CT, that's a current transformer, to measure the current.
Right.
Okay, and then for the voltage, that is 230 volts, I would use a resistive divider.
Okay.
So that would bring down the 230 volts to something which is like a 5 volt, which the microcontroller ADC can accept directly.
And your controller had an inbuilt ADC or?
Yes, this controller had 9 inbuilt ADCs. So, it's for 3 phase. So 3 input voltages, 3 output voltages and 3 currents. So it got like used to the fullest.
Right.
Yeah.
Very satisfying when you use it.
Sorry?
It's very satisfying when you use all the peripherals.
Yeah, that is true. You get maximum money for your, maximum